Looking at this open-pit mine in the Deccan Plateau, the sheer scale of the extraction infrastructure gives you a sense of the deep, raw mineral wealth buried in the earth. Compare that stark industrial extraction to this landscape, a dense, undisturbed forest canopy extending across mountain ranges, a sprawling, living, self-reproducing system. And then there are expanses like the Thar Desert. It looks entirely barren, yet beneath that bright sky lies immense solar and wind energy potential. Nature distributes its wealth with an extremely uneven hand. It creates dense pockets of intense abundance and vast stretches of extreme scarcity. When extraction happens without a systematic way to track these elements, their location, their behavior, and their legal boundaries, the result is a gamble. We risk depleting the very resources we depend on before we've even finished cataloging them. Bringing order to nature's geographic chaos requires a cartographer's logic. The first layer of that map is origin. We categorize living, reproducing elements like wildlife and flora as biotic resources. Conversely, abiotic resources are the non-living physical elements forged by geological time, rocks, landforms, and minerals. But identifying where a resource comes from is only the beginning. The second layer measures our development status, the critical difference between knowing a resource is there and possessing the technology to actually extract it. Look at the concrete structure actively interrupting this river. We know the exact quantity of water flow and have the built infrastructure to harness it right now. This is classified as an actual resource. That is entirely different from a potential resource. The Thar Desert has massive reserves of solar and wind energy, but until widespread infrastructure is built to capture it, that value remains potential. Knowing a resource's origin means very little if we don't honestly assess our technological readiness to utilize it properly. The third layer of classification measures renewability. Non-renewable resources, like fossil fuels, exist in strictly finite supplies. They require millions of years of geological pressure to form. Renewable resources, on the other hand, are elements the Earth can naturally replenish over a standard human timescale, things like forests, soil, and groundwater. Here is where a dangerous misconception takes hold. People assume the label renewable means inexhaustible. In reality, only resources completely immune to human overextraction, like sunlight, are truly inexhaustible. This industrial combine harvester illustrates the scale of modern agriculture. In Punjab, a transition to water-intensive, high-yield crops drove groundwater extraction rates far beyond the Earth's natural ability to recharge the aquifers. As a result, the water table plummeted out of reach. A vital, technically renewable resource was effectively exhausted for current generations. Renewability offers no magic shield against collapse. A resource is only renewable if our rate of consumption respects nature's speed of recovery. The final two layers of our map detail how physical distribution intersects with human political boundaries. First, we look at distribution. Resources found everywhere are ubiquitous. Isolated geological pockets are localized. Ownership dictates management, fragmenting the map. It starts with individual resources, like a private field. Scaling up reveals community resources, like shared ponds. Stepping back, national resources emerge, encompassing territorial waters. Past the exclusive economic zone lies the open ocean, international resources requiring multinational treaties. These shifting scales of ownership dictate exactly who holds the power and the legal responsibility to manage nature's uneven distribution. When we apply this classification matrix to the physical terrain, the map upgrades from a simple geographic view to a precise ledger of our natural wealth. But possessing abundant natural endowments does not automatically guarantee economic development. Regions overly reliant on a single abundant material often experience the natural resource curse, where poor management leads to economic stagnation, corruption, and environmental ruin. Mapping our resources is only the diagnostic. If a resource is non-renewable, we stretch its life through recycling. If it is overexploited, we enforce extraction limits. Stewardship is the act of aligning our economic ambitions with these physical realities. True sustainability is achieved only when we respect the strict physical boundaries defined by nature's map.